Topic 7 of the SCR program focuses on climate models and scenario analysis as essential tools for understanding and managing climate-related risks. The topic explains how organizations, financial institutions, and policymakers use climate scenarios to evaluate possible future outcomes associated with physical and transition risks. Climate scenario analysis supports strategic planning by helping organizations assess vulnerabilities, estimate potential impacts, and prepare for uncertain environmental and economic conditions. The program emphasizes that climate models are not designed to predict exact outcomes but rather to explore plausible future pathways that inform decision-making, resilience planning, and long-term sustainability strategies across industries and financial systems. The topic begins by introducing climate scenario analysis as a structured planning methodology used to evaluate potential future developments under varying climate and economic conditions. Scenario analysis helps organizations assess how different emissions pathways, regulatory responses, technological changes, and market transitions could affect business operations, investments, and financial performance. The SCR program highlights that climate scenarios are particularly valuable because climate change involves long time horizons, significant uncertainty, and interconnected risks. By evaluating multiple scenarios rather than relying on a single forecast, organizations can strengthen strategic flexibility and improve preparedness for evolving climate-related challenges and opportunities. A major focus of Topic 7 is the study of global net zero scenarios and decarbonization pathways. The program explains how governments, corporations, and international organizations develop scenarios designed to limit global warming and achieve net zero greenhouse gas emissions. These scenarios often include assumptions regarding renewable energy adoption, energy efficiency improvements, carbon pricing policies, technological innovation, and carbon removal processes. Candidates learn that net zero scenarios help policymakers and businesses evaluate transition risks, identify investment priorities, and assess the feasibility of achieving climate objectives within targeted timeframes while balancing economic growth, energy security, and sustainability considerations. The SCR program also introduces key climate reference frameworks developed by international scientific and policy organizations. Candidates study the Intergovernmental Panel on Climate Change (IPCC) scenarios, including representative concentration pathways (RCPs) and shared socio-economic pathways (SSPs). RCPs describe different greenhouse gas concentration trajectories, while SSPs outline varying socio-economic development assumptions that influence climate outcomes. The program further examines International Energy Agency (IEA) scenarios and other global reference models commonly used by corporations, regulators, and financial institutions. Understanding these frameworks enables professionals to interpret climate projections and apply standardized approaches in climate risk analysis and strategic planning. Another important topic covered in the topic is scenario development and model design. Organizations must make several key decisions when constructing climate scenarios, including selecting time horizons, defining assumptions, identifying material risks, and determining analytical methodologies. The SCR program explains that effective scenario analysis requires balancing scientific credibility, business relevance, and practical usability. Candidates learn that climate scenarios should reflect organization-specific exposures, geographic conditions, sector dynamics, and strategic objectives. The topic also emphasizes the importance of transparency regarding assumptions and limitations, recognizing that climate modeling involves uncertainty and evolving data availability across environmental and economic systems. The topic examines how climate models and scenarios are used to assess transition risks affecting businesses and financial institutions. Transition risk analysis evaluates the potential impacts of policy changes, carbon pricing, technological disruption, market shifts, and changing stakeholder expectations associated with the transition toward a low-carbon economy. Organizations use these analyses to identify vulnerable assets, estimate financial exposure, and evaluate strategic adaptation options. The SCR program explains that transition scenarios help firms assess competitiveness, investment alignment, and operational resilience under different regulatory and economic conditions while supporting long-term strategic planning and sustainable business transformation efforts. Physical climate risk assessment is another critical area explored in Topic 7. Climate models help organizations analyze exposure to hazards such as flooding, droughts, heat waves, wildfires, sea level rise, and severe storms. The program explains how scenario analysis can estimate the frequency, severity, and geographic distribution of climate-related events under different warming pathways. Companies and financial institutions use physical risk scenarios to assess infrastructure vulnerability, operational continuity, insurance exposure, and supply chain resilience. These assessments support adaptation planning, disaster preparedness, and investment decisions aimed at strengthening resilience against long-term environmental and climate-related disruptions. The topic concludes by emphasizing the practical applications of climate scenario analysis within corporations and financial institutions. Organizations increasingly integrate climate scenarios into enterprise risk management, investment analysis, capital allocation, and regulatory reporting processes. Financial firms use scenario analysis to evaluate portfolio exposure, conduct stress testing, and manage climate-related financial risks. The SCR program highlights that scenario analysis is not intended to eliminate uncertainty but to improve organizational preparedness, resilience, and strategic decision-making. By understanding climate models, global reference scenarios, and analytical methodologies, professionals can support more informed climate risk management and contribute to sustainable long-term economic and financial stability.